It's Gary live from Manchester.
Yeah. Alright, here we go. NH4 positive. Whatever. You guys act like that isn't cool.
I just helped you out. I just helped you out.
Way deep down. Like way
I just helped you out.
Right?
It's about as cool as painting your face for us.
It's as cool as Justin Bieber.
Painting your face can be a good thing. It depends.
Like
or paint your hair.
Okay, let's move on.
Alright, NH, I agree. We're ready to spend time on the film here. So NH4 plus. So first of all, again, this is an ion. We're going to have to account for the fact that it's positively charged when we do our electron calculation. Now this one's real simple for figuring out what the central atom is. Because the central atom can never be what element? Hydrogen. So you don't even have to look anything up. Can't be hydrogen, leaves nitrogen as your central atom. Now, NH4 plus for valence purposes. Nitrogen. How many valence?
5.
5. Good. We're shouting out the right numbers this time. Hydrogen. How many valence does it have?
1.
I don't want to say your name out loud.
Jasper.
So, hydrogen, how many does it have?
1.
1. And you got 4 of them.
Do you
So
see
1, 1, 1, 1. Now, you have one more thing you have to account for. This is positively charged, meaning this thing has lost an electron. It's positive because losing an electron, which is a negatively charged thing, leaves it plus 1. Leaves it one more proton than electron. So, because of that, we got to subtract 1. So, nitrogen, 4 hydrogens, the minus 1, because it's plus 1 charge. So our total is 5, 6, 7, 8, 9, minus 1, for a total of 8. We put our nitrogen in the middle. And I'm going to draw this one wrong on purpose. We'll make this like a 3-legged stool. At least I think I'm drawing it wrong on purpose.
Yeah.
So we can fix it then with the Vsepr later. We'll make this one like that. Like 3-legged stool. So when we did our single bonds there, how many electrons did we use up?
4.
Well, 1, 2, 3, 4, 5, 6, 7, 8, right? So minus 8, none are left.
Yes.
Now, hydrogen. How many electrons does it want?
2.
2. So they're happy, all my hydrogens, aren't they? Nitrogen, is it an exception? No, it wants 8. Well, nitrogen is 2, 4, 6, 8. So nitrogen is happy. So do we have to draw resonance structures on this one?
No.
No. So what I want to point out to you is, just because it's an ion, doesn't mean that it has, 3 drawings like on the last one.
Could.
It could, but in this case it does not. The only thing we got to do now is we got to verify that I've written it correctly from the Vsepr, and I really don't think I have. Nope. So we look at the central atom nitrogen, and we look for things that are bonded to it, atoms that are bonded to it, and how many lone pairs there are. Well, there is 1 hydrogen, 2 hydrogens, 3 hydrogens, 4. Are there any lone pairs?
Nope.
No.
Hope not.
So I go on here, and I find where it's 4 things, 4 bonded structures, 0 that are lone pairs. And I find that I should have drawn something that was tetrahedral. So bummer, we did not do it correctly. So we have to adjust our drawing. Nitrogen, hydrogen, hydrogen, hydrogen. So it looks like a big X. Now, let's say I drew it like this. Is that wrong? No, just take your head and tilt it a little bit. It would look exactly like that. There is one last thing.
So it was right?
So
there's
one last thing though that we do have to do.
Okay.
Brackets and a plus charge. And likewise, I guess we do the brackets. These are not resonant structures, okay? Because these are the exact same structure, just, like I said, tilt your head. All right, another example done. Kirby from Manchester, out.